In this video, I will discuss the three major types of data warehouse schema. So let's start our discussion by defining a multidimensional model. So a multidimensional model is specially designed to model data warehouse systems. The schema are designed to address the unique needs of a very large database designed for analytical purposes, or the OLAP. So the dimensional data model may actually consist of three major schema or type. So we have star schema, we have snowflake schema, and also fact constellation schema. Let's discuss them one at a time. Let's start with the star schema. So the star schema is also known as star joint schema, which is actually given star schema because its structure resembles to a star. So this is considered the simplest type of data warehouse schema. So star schema can have one fact table. We have already discussed fact table last time, and a number of associated dimension tables. So the fact table would contain key and also measure. So the dimension on another hand, uh, these are tables joined. The dimension tables are actually tables joined to the fact table using the foreign key. So in the star schema, the dimension tables are not allowed to join to each other. So the star schema is considered denormalized. Okay, so when we speak about denormalized, so definitely our design here is not in the third normal form. Okay, so denormalized, uh, not in third normal form, so that means that dimension tables are not normalized. So meaning the normal rules of normalization applied to transactional relational databases are actually relaxed during the star schema design and implementation. Okay, so the reason why we perform the normalization in the star schema is that we want to optimize querying of large data sets. So the star schema is widely supported by different business intelligence tools. Okay, so this is our example of star schema. So in this particular example, we have a fact sale considered as our um, fact table. So connected to this fact table are three different dimension tables. So we have dim date dimension, dim store dimension, and dim product dimension. So notice that we instead of, aside from having natural key here, our primary key, we also have ID. So the ID in the different dimension tables is considered surrogate key. So as we mentioned, surrogate key are system generated key or warehouse generated key. Okay. So what are the benefits of star schema denormalization? First benefit is simpler queries. Okay, with the normalized structure of star schema, so the joins are actually lessened. Okay, so this is simpler compared to normalized transactional schema. It's because in normalized structural schema, so as we know, parang spaghetti yung design. So that means there are more joins. Uh, there are more joins that are actually allowed. Okay, so query performance gains is another benefit of star schema denormalization. So this simply means star schema provides a performance enhancement for read-only reporting application. So this is in compared to the highly normalized tables that we used in our traditional transaction processing system. So it also allows fast aggregation. Okay, so when we talk about aggregation, so we talk about, let's say, summing up of values, um, grouping, yung performing counts and others. Okay? So we have faster aggregation in store schemates because, as mentioned, we have simpler queries resulting to improved performance of aggregation operations. Okay? So we also have disadvantages of star schema denormalization. And the number one disadvantage is data integrity problem. Okay? As we know, we always ensure that um, the data are normal, or the in transactional system, we make sure that our resultant tables are in third normal form, normalized. We enforce referential integrity because through that we can actually improve data integrity, or we can enforce data integrity. Since here we are talking about the normalization, so we usually did not apply referential integrity. Alongside with that, data integrity may actually um, be compromised. Okay, so it also tends to be more purpose built for particular view of data. Okay, so however, since it allows, sabi natin, simpler queries, so this remains the favorite in data warehouse schema. Okay, let's have this an example. Okay, I want to know how many TV sets have been sold for each brand and country in 1997. So this example was taken from Data Mining Concepts and Techniques by Han et al. Okay, so this is our sample diagram. So we have your fact sales. The same example I provided in the previous diagram, and we have three-dimension tables here. Okay, so let's see the equivalent SQL code that will allow us to solve that particular given problem. So we should issue select P brand, S dot country as countries, and sum F units sold from the fact table joined together to the dimension table, and also to store table, and also to product dimension tables. So we join two tables together using common column. We have our join condition here for first join condition, second join condition, third join condition, and fourth join condition. So rule for implementation of aggregate function. So if we have ordinary columns present in our select list, we should perform group by. So therefore we have a group by P brand and comma S country. Okay, so this is how we actually answer this particular problem. Okay, so that is just basic example of implementing the star schema. Okay. Let's move to the snowflake schema. So the snowflake schema uh, is the resulting schema graph that actually forms a shape similar to a snowflake. Okay, so this is a variant of star schema model where some dimension tables are normalized. Okay, so normalized hereby further splitting the data into additional tables. So the major difference between Snowflake and Star Schema is that the dimension table in this model, in the Snowflake model, may be kept in normalized form to reduce redundancies. Okay, so this may reduce the effectiveness of browsing kasi sabi natin if there are more joins, so probably medyo mas mabagal. Okay, so more joins will be needed to execute a query. So consequently, a system performance may be adverse, adversely impacted because of the many joins available in the Snowflake schema. So hence, although Snowflake schema reduces redundancy, it is also not as popular as star schema in the data warehouse design. Our example of Snowflake schema is this one. Okay, so this is the same diagram presented in your module. So in this particular example, we have here several dimension tables, student, teacher, plus other dimension tables connected to some other dimension tables. So this particular table is considered our fact table. Okay. So in here, we just show hierarchies in in our design. Okay. The third one is called fact constellation schema. So this is called fact constellation schema, um, also known as galaxy schema, because it contains two fact tables that share dimension tables between them. Okay, so therefore, the fact constellation schema has multiple fact tables to share dimension tables, such as in this one. Okay, so parang constellation. So in this particular example, we have fact tables, two fact tables, and these fact tables uh, are connected to dimension tables, branch, and date. They shared two dimension tables. They shared two dimension tables. Okay, so those are the three uh, schema, data warehouse schema that are considered most popular. Okay.